Okay, so here we have a few examples that we'll do using the chain rule. So starting off in this first example, remember that cosecant was one of our trig functions, and we found last time that the derivative of cosecant of x is equal to negative cotangent x cosecant x, right? So what we can do now is use the chain rule to compute this. And so our outside function is cosecant of x, and our inside function is going to be 8w. Okay, so the first thing we do is we take the derivative of cosecant, which we've written right here, and remember that this is evaluated at the inside function, so we have to have 8w inside. So notice that wherever there appeared an x in my derivative of cosecant x, I replace that with 8w, so in those two spots. Okay, now we multiply that by the derivative of 8w, which is just 8, right? Okay, so once you get used to using the chain rule, you don't have to write down all these steps where you say, oh, the outside function is this, the inside function is this. Although it can be helpful while you're learning it, sometimes it almost makes the problem harder because you have to figure out how to label things, and sometimes it's easier to just go directly for that. So I'm going to do that in the next example, and hopefully you can see what I mean by that. So what we have here is we have 5 plus e to this power of stuff. So first of all, the derivative of 5 is 0, and then we want to take the derivative of e to the 4t plus 7 plus t to the 7th. So we know that the derivative of e to the x is just e to the x. So what we're going to get is e to that same thing where we leave everything in the exponent alone, right? So that's the derivative of the outside function. Okay, and then we multiply it by the derivative of whatever this stuff in the exponent. So it's 4 plus 7t to the 6th. That's just using the power rule on those pieces. And this is the derivative of the inside function. Right? Okay, so let's rewrite this. We can put this out front times e to the 4t plus t to the 7th, right? Okay, so without having to label everything, it's a little bit easier to just write down the answer. So you may want to take that route when you're doing problems. Okay, now in this last problem, we can do this using the chain rule. But there's actually an easier way of doing it. So when you're looking at this function, you see that the square root of x is inside of another square root, right? So we can use a chain rule here. And so our inside function is square root of x. Outside function is square root of x as well. So g prime will be equal to, if this makes it a bit easier, we'll write this as x to the 1/2. Wait, maybe, yeah, like that. Okay, so using the power rule first, on the outside, we get 1/2, x to the 1/2 stays the same, and then it'll be raised to the power 1 minus 1/2, so negative 1/2. And then we multiply that by the derivative of this inside function. So multiply that by 1/2 x to the minus 1/2, right? Okay, so now being very careful with our exponents, we're going to simplify this. So I have a 1/2 here and a 1/2 there, so that will be 1/4. And then x to the 1/2 to the, so remember when we have x to the a to the b, maybe I'll write this as, so this is one of our exponent laws, this is equal to x to the a times b, right? So we just multiply these two together to get, I guess that's not necessary anymore, x to the negative 1/4 for that piece, and then we still have x to the minus 1/2. And then another one of our exponent laws is if we have x to the a times x to the b, that's equal to x to the a plus b. So we're going to add these exponents to simplify even further, and we'll get 3/4 if we find the common denominator there. And I think I'll just leave it in this form, or let's rewrite it as 1/4. So the negative means that this will go in the denominator, and then we'll have the 4th root of x cubed, right? Okay, but as I said, there is an easier way of doing this. So you may have noticed that we had x to the 1/2 to the 1/2, and we can rewrite that as x to the 1/4, right? And then, just using the power rule, g prime is 1/4 x to the minus 3/4, which we see is exactly the same as what we got using the chain rule. And right, we get the same answer. Okay, so it's good to check that you get the same answer doing it different ways. But usually you want to use the easiest rule that you can come up with. And so the power rule is going to be much easier than the chain rule. There's a lot less chances for mistakes, right, when we're using the power rule. So look out for problems like that. Of course, you can always use the chain rule. So if you want to do it a certain way, I'm not telling you that you can't do it that way. Okay, so that's it for examples, but we will have another section or another group of videos on this section next time as well. So don't forget to do the comprehension check question.